Charger Lab has published several teardown videos of Anker chargers in the past, and today we got another brand new Anker 100 watts GaN charger, which is equipped with two USB-C ports and a USB-A port. Let's try to take it apart and check what's inside. The packaging continues the classic blue and white, and the selling points, name, model, and certification are on the back. Open the box, here are the charger and manuals inside. The charger continues design of the Anker Series 7 with a black-gray shell with the top silver panel. All of those three ports are blue. It adopts fixed bronze, and here are the specs info. Model is A2145, and here's the charging guide. The charging power will be automatically distributed when you use different ports. You can pause to take a look. The size of this charger is about 56 by 66 by 31 millimeter, so the power density is about 0.83 watts cubic centimeter. And the weight is about 205 grams. And then the 3-port Anker charger is even smaller than single-port Apple 96 watts charger. The Charger Lab Power ZKT002 shows the USB-C one can support QC2, QC3, FCP, SCP, PE2, PD3, and PPS protocols. It also supports 4 fixed PDOs of 5 volts, 3 amp, 9 volts, 3 amp, 15 volts, 3 amp, 20 volts, 5 amp, and a set of PPS. And the USB-C 2 is the same as USB-C 1. The USB-A supports QC2, QC3, FCP, SCP, PE2 protocols. Okay, and the next step is to take it apart to see what's inside. Pry along the gap. We can finally remove the top case. We can see lots of silicon adhesives inside. The PCBA module is covered with copper heatsinks. The red and black wires are connected to the input bronze. Let's remove the heatsink on both sides. The front and back components are covered with silicon adhesives for fixing and heat dissipation. And then let's clean up the silicon adhesives. Now Charger Lab found it adopts QR topology and has a PFC circuit. The secondary step-down circuit can adjust the output power of each port. Then let's start from the input to introduce all components. Firstly, the time delay fuse is from Better Electronics, 3.15 amp, 250 volts. The first common mode choke is used to suppress EMI interference. The safety X2 capacitor is from DGCX, 0.47 microfarad. The second common mode choke is slightly different from the first one. And then the bridge rectifier is from Pingwei, which can convert AC into pulsed DC, 8 amp, 1000 volts. The first film capacitor is 1.2 microfarad, 450 volts. And the second one is from DGCX, 1 microfarad, 450 volts. This is the toroidal core inductor. This charger is equipped with PFC circuit, and the PFC controller is from ON Semiconductor, which operates in the critical mode with enhanced high efficiency. The PFC GaN IC is from Navitas NV6136A, which integrates the current sampling technology and driver. It adopts QFN6x8 package and can support 2 MHz switching frequency, 170 milliohm 10 to 30 volts. The PFC boost rectifier is a fast recovery diode. Here is the PFC boost inductor. This electrolytic capacitor is from Anshi and is used for PFC output filtering, 420 volts, 120 microfarad. The primary controller is from Southchip SC3022D, which is a high-frequency QR flyback controller. It integrates X capacitor discharge and high-voltage startup. It also provides an adaptive switching frequency fold back to achieve higher efficiency in the whole loading range. The primary switch transistor is also from Navitas NV6136A, same as the PFC GaN IC. The transformer is tightly wound with insulating tape. Here is the EL1018 optocoupler for the feedback of output voltage. Two SMD-Y capacitors are on the top and middle of the PCB from Anshan KFET. Two parallel synchronous rectifiers are from Vergiga, which adopts PDFN 5060 package, 120 volts 6.5 mA. The synchronous rectifier controller is marked with 903A and adopts SOT23-6 package. Two solid capacitors are soldered vertically on the PCB for output filtering. The first one is 680 microfarad, 25 volts, and the other one is 470 microfarad, 25 volts. Then the pulsed DC will be sent to those secondary step-down PCBs, 3 in total. Since both USB-C ports can support 100 watts, those two PCBs are identical. The filter capacitor and inductor are on the front, and the master control chip of two USB-C ports is from iSmartWare SW3516H and used for step-down control and protocol identification. There is a MOSFET for the USB-C port from AOS, 30 volts 6.3 mA. Those two MOSFETs are used for synchronous rectification and step-down, marked with S4480. The output V-bus MOSFET is from AOS and adopts DFN 3x3 package, 30 volts 5 mA. Finally, the solid capacitor on the front is from Yongming MPT series, 220 microfarad, 25 volts. And then this is the secondary step-down PCB of the USB-A port. The protocol chip is the same as USB-C port from iSmartWare. Those two synchronous step-down MOSFETs are the same as USB-C ports, and the solid capacitor is also the same as USB-C ports. The USB-A socket is blue. There is a chip CMCU on the secondary side for power distribution, overheating protection, and PFC control. It also integrates a 12-bit ADC and LED driver. The thermistor is used to detect the temperature of the transformer. Well, that's all for this Anker 100 watts charger. It's equipped with two USB-C ports and a USB-A port, so you can charge your phone, tablet, and laptop at the same time. Since it's pretty small and can support up to 100 watts, it takes many measures to control the temperature. For example, it is filled with silicon adhesives, and there are pure copper heat sinks on the front and back sides. After taking it apart, ChargerLab found it adopts chip CMCU to control the output power, and most components are from some famous brands like Navitas, Vergiga, ON Semiconductor, Southchip, Anshi, iSmartWare, etc. Okay, that's all for today's video. You can also click the corners to view the teardown videos of other Anker products. Please drop a like, leave your comments, and subscribe to us. See you in the next video. Bye.